For what values of m does the equation 6x squared minus mx equal to negative 3 have two equal roots? So what are we looking for? We're looking for m. So m is just some number, and it appears in this quadratic equation. And we want to pick m so that this equation has two equal solutions. Or graphically, right, on an xy axis, if we were to graph the quadratic, it would have two equal roots, so that means it would have one x-intercept. Before we even begin, just looking at this quadratic, it's not in standard form. So let's just get it to standard form first by adding 3 on both sides. Plus 3 equals 0. Right, so this form is super useful to us. So it's the ax squared plus bx plus c equals 0. Right, standard form or general form. Because we can use the discriminant, we can use quadratic formula, put it in on a calculator. So that's a good starting point. So taking it to standard form. Now, for this equation to have two equal roots, hopefully you remember the discriminant. We denote that as delta must equal 0. So for two equal roots, the discriminant must equal 0. The other two cases, which aren't relevant here but are good to know, is no real roots. So that's where there are no x-intercepts, and that's when the discriminant is negative. And then, of course, there is the case where there are two x-intercepts, and that's when the discriminant is positive. But for this problem, we want to know the value of m so that there are two equal roots, or one repeated x-intercept. So the discriminant is defined as b squared minus 4ac, where a, b, and c are just numbers from our quadratic equation. So b is the coefficient of the x term, a coefficient of x squared, and c is the constant. So substituting those in, we can work out our discriminant. So b squared is negative m squared, but being careful here that we put brackets around the m. So right on our calculator, just to demonstrate, negative 4 squared. When I say that, you'll be thinking 16, right? However, actually, with correct BEDMAS, we would square the 4 first and then multiply it by the negative 1. So just be sure to use your brackets here. And we minus 4 times a, which is 6, times c, which is positive 3. And that gives us m squared minus 72 is our discriminant. Now, we just said earlier for two equal roots, our discriminant must be 0. So 0 equals our discriminant, which is m squared minus 72. Add 72 to both sides and square root both sides. Gives us m equals plus or minus square root of 72. So to recap this one, we started with a quadratic equation. It wasn't in standard form, so that was our first step. We then identified the coefficients a, b, and c, put them into the discriminant equation to work out our discriminant, which we then set equal to 0 because the nature of the problem asked us to have two equal roots. This step here is where you might, instead of setting it equal to 0, set it greater than 0. For this scenario of two distinct roots, or set it less than 0 for no real roots. We then just solved for m by adding 72 on both sides and then square rooting.